Here we go.
Thank you. Thanks, Mike. I appreciate that introduction. I do miss the conversations that we used to have in Austin. So just for the audience, yeah, we were quote unquote pricing scientists. Today you'd call those data scientists, right? With a pricing subject matter expert, I guess. So I really appreciate the time to be able to present tonight and to see an old friend. So with that, let me take it away. And as Mike said, one of the things that really got us re-engaged was the book just came out, and so we started texting on LinkedIn, and so this book was something that I've been planning for years, the old Dell days, and then Dell is a marketing machine. I've seen a lot of good books over the years with an application for specific know-hows, how-to things to do in, you know, everything from business intelligence to statistics to data science of all flavors, some really good how-to books. But what I didn't see is really kind of the foundations of how the building blocks fit together. So, you know, there were books on, you know, Python and R and Scala and Java, you know, you name it, neural nets, you know, how to do machine learning and everything from a practical standpoint. But as someone that has kind of had a varied background, covering a lot of different things, I didn't see that for most professionals how these things fit together. And so that's really going to be that was really one of the main pillars of the book, was data literacy. And that's going to be one of the main pillars of our talk tonight. So with that, there are kind of three themes that I want to go through, and I'm not going to separate these themes. I'm actually they're going to kind of be incorporated in a lot of the different topics. You know, when I went through this mentally, I was trying to think, well, should I try to separate these, or should I just, there's so much interplay, it just makes sense to talk about them as we go through some of the topics that I want to share with you tonight. So, you know, the first one is democratizing analytics. You've probably seen that. It's a term that's floating around right now, right? So power of analytics to the masses. I like team sport better, really, because data science to me and data-driven intelligence is really kind of a team sport that different members with different talents can bring together. And so the second piece is the need for data literacy. I'm gonna motivate that in just a minute. And then the last theme is really better together, on how these things play. And that's my view, that we need everything here, and we need the methods to work together, and we need the people with different skill sets to work together as well. So as part of the motivation, you know, is data the new oil? You know, it's that's kind of been hyped out there. The real thing about data is the fact that data is really just a cost. It's really a liability. I mean, it takes money for you to even source data in the first place. It takes money to, you know, store it, to keep it. It's also, you know, has anybody heard of a data breach anywhere? You know, it's a security risk. Anytime you have this data sitting around and it's not being used, it's a major cost and a major risk. So it's only through turning that data into value that organizations can really thrive. So, you know, you can provide you can monetize the data, and you do that through, you know, data science, machine learning, analytics. I'm sure I'm speaking to the choir here. I'm sure everybody here, that's what the reason that they go to work every day, most likely. So, but one of the things in the book that I like it's a quote. It's really not the technology that's hampering the progress. It is the lack of vision, human capital, and execution. And that's one of the pieces that, again, I saw missing in the books that were available, and kind of motivated me to do this. So I'm not sure if you've seen a slide like this. This is adapted from Rensselaer. And the idea is that data has been and continues to grow exponentially. So we're sitting here, in the year 2020, and, we're sitting at about, 45, 50 zettabytes. And by 2025, they're estimating about a four-fold increase, right, up to 175 zettabytes. So there's lots of sources that are providing this, but one of it certainly is IoT, the Internet of Things, or the Internet of Everything. And you can just look, I won't go through all these stats, but when you think about the second bullet there, and the fact that there are 30 billion connected devices this year is the estimate, and there's 7 billion people on the planet. So you get kind of a sense of just the explosion of the data that's traveling through our networks, right? And unfortunately, less than half of the structured data is actively used in decision making, and it's up to all of us on this call to make that happen, right? And then what's even worse is that, when you look at the unstructured data, which is most of the data out there now, less than 1% is actually analyzed or used at all. And some people call this dark data, actually, all this data that's out there and that's not being used at all. So with that, this is kind of a rant slide. I apologize, but we don't have good data or statistics in my mind, at least not as good as we should have. And there are a few things that are causing that. When I was with Dell, again, Dell was a marketing machine. Dell does great work. They've got great people. They have great products, but they also have marketing spend that you wouldn't believe. When I was there, we were talking about big data, big data, big data. And that's one of the things that clouds the data literacy, is all of these terms, many of them being put out there like they're something new, when they're just essentially a reinvention of one sort or another. And I get it, believe me. I mean, you got to differentiate yourself and your products and what you're doing. So you got the marketing hype that's going on. You got the self-promotion going on. I mean, I'm self-promoting right here during this talk, right? And so I get the reason, but you need to try to be an informed consumer of all this. The media, there's so much hype in the media, and of course the political hype that's going on as well. So I remember when I was at Baylor, I had an econometrician professor, and one of the things that he told the class one day is he said, whenever you're reading something, you should ask yourself, why is this person lying to me? And I thought, well, man, that's pretty cynical. That's really, I didn't get it. That's kind of crazy. But believe me, I get it now. So again, it's not that it's a good thing or a bad thing. It's just that these biases exist, and you just need to be an informed consumer about it. And then just since this is a rant slide, I like the little meme on the lower right here. I'm sure everybody has dealt with, data sets being garbage. To the point of the first bullet there, right? So I've been hearing for 30 years that we need to be data driven, right? So we're still saying it. So what happened? Well, one of the things is that the data available often is garbage, and so it's for all of us to clean up. And then just one last rant is, I've been really disappointed with the whole COVID thing. It's as a statistician, I see these things all the time portrayed as just lump numbers, maybe varied a little bit by geography, but pretty much nothing else. I mean, I kind of gave up early on when none of the numbers being reported were the numbers I wanted. And it just really kind of irked me. And of course, too much of that type of data will make you go crazy anyway if you look at it too often. But we have 330 million people in the U.S., and to treat everybody as the same just really kind of irked me. So I want to know what's my individual risk, right? I want to know what my family's risk is, and yet all the stuff that you get is not broken down by frequency, by category, stratified in any way. So I'll quit. I'll quit there. So this is a quote from, actually two quotes from Howard Dresner, and he did a book forward for us, and I thought they were really good. And he's been saying, he came up with this idea of information democracy almost 30 years ago. It kind of plays along the lines of analytics democracy, but the point there is delivering information to every point of the organization where it's needed. And we have come a long way there. We have a long way to go, but pushing this down to the right people at the right time. But he has also in this forward, he talks about that there's, according to their research, 43% indicate that they consistently use data in their decision-making process. And only a third of organizations claim high or extremely high data literacy. So again, we have a long way to go, and we're in it together, right? So we need to be presenting the best information possible and consuming the best information possible. And then the last bullet, again, goes back to one of the reasons that we wrote this book was the fact that there's so many buzzwords around, and I'm going to show you some of that soup here in just a minute. I really like this. I'm just going to actually read this word for word because I like it so much. These two bullet points, both of them come from people from Gartner. But imagine an organization where the marketing department speaks French, the product designers speak German, the analytics team speaks Spanish, and no one speaks a second language. That's essentially how a data-driven business functions when there is no data literacy. Casey Panetta. The prevalence of data and analytics capabilities, including artificial intelligence, requires creators and consumers to speak data as a common language. Data and analytics leaders must champion workforce data literacy as an enabler of digital business and treat information as a second language. Valerie Logan. So I really like both of those, and that is something that we all need to work on. I can tell you that I'm not always good, and I'm going to admit a couple of my fallacies in this conversation tonight. And then, half the organizations lack data literacy skills. So again, we need to educate across the whole organization. And to that effect, you can't really just stay in your lane, right? You can't stay in your lane because analytics traverses the entire organization, and everyone, although different level consumers or producers, need to know different things, everybody really needs some basic data literacy across the organization. And again, even to be an intelligent consumer, you need that as well. And again, why is this person lying to me? It's cynical, but it's often true. I mean, if you buy things, for example, I use ratings a lot when I purchase something, and but I won't necessarily choose something that has a high rating if there's two people that have provided the reviews. You need more information. So that's need to be a smart consumer. And I remind myself of the last bullet all the time because you don't have to be an expert. There's no way that you can be an expert in everything, but you can educate yourself kind of across the spectrum, and so that's what I try to do. All right, so this comes from another forward in the book. So again, this is from Dr. Cromwell. He's a medical doctor, just a super bright guy. But the one thing that I want to tease out here, I mean, I think the whole thing is good, but the thing that I love is that, you know, many people need to know, many who need to know don't even know what they don't know. I'm sorry, let me say that again. Many who need to know don't even know what they don't know. So I thought that was pretty poignant, and you know, again, it's because we're siloed often in organizations across, you know, barriers. So this is the slide that I mentioned a little bit ago. This is a really ugly slide. It's actually meant to be an ugly slide, and it's because all these terms and all this stuff, as we're getting, you know, more data, we're getting more specialized. It's growing, right? So in the book, we talk about different types of analytics, and actually one of the reasons that the title of the book is It's All Analytics was when we're looking at statistics, data science, business intelligence, operations research, optimization, et cetera, one of the things that really kept bubbling up was analytics. And so in the blue bubbles, you can see there that there are a number of different types of analytics, right? And some of these are by where the application is, for example, sports analytics, or, you know, public policy or health analytics. But then there's also ones that are by methodology, like, you know, text analytics, or, you know, predictive analytics, et cetera. So, and again, we included 50, but there's literally hundreds of different quote unquote analytic types out there. So, and then of course you can add all the data science, all the statistical terms, et cetera. And so really it does, it's a soup, right? And so analytics was kind of the overarching term, the one that made most sense to use. And so when we try to categorize these, this is probably the best that I've come across. I've actually augmented this slide, but the basic 4 types of analytics that are out there. Gartner, you'll see this in some of Gartner's documentation. They're a big analyst firm for IT and data science and others. Is this idea of descriptive analytics, diagnostic, predictive, and prescriptive analytics, those 4 major categories. And you can see kind of what they mean, right? So descriptive is all about, well, what happened? Diagnostics is why did it happen? Predictive analytics is what will happen. And then prescriptive analytics is how can we make it happen? And then the thing that really intrigues me, this idea of cognition, right? So when we talk about all this stuff, cognition happens in 2 places. It either happens in a machine, a computer, or your head. And I should say machines, not the single machine. But the idea is that almost virtually everything ultimately ends up, unless it's an automated action within machine to machine, there is some cognition, right? Some human cognition that happens. And, you know, on the lower left, when you talk about descriptive analytics, let's just say like a dashboard, right? So, you know, like a Tableau dashboard or Power BI, et cetera. You look at these dashboards, and most of the cognition happens in the person's head, right? There's not a lot of computer power that goes into creating a dashboard, right? It's compared to, let's say, some sort of deep learning AI algorithm that might be used for, you know, predictive or prescriptive analytics. A lot of that actually happens in the machine, right? The machine is doing the hard work, and then the machine is presenting the results to the human for the final view and consumption. So I'm fascinated by kind of the trade-off where these things happen. And so I kind of created that human processing, machine processing slider there. And, you know, the hindsight, everything in descriptive analytics is, you know, in the past. And then the foresight moves to the foresight where we're predicting things about the future in predictive and prescriptive analytics, and then even process optimization, right? What is the best action that we can take? And then the other thing that I want to really impart tonight is if you look at the red boxes, all those require causality. And most people, I can tell you, a lot of people that I highly respect do not understand the difference between prediction and prescription. And we're going to talk about that tonight. All right. So this is, one of my favorite shows is The Office. And Michael Scott, in one episode, he's underwater and he's having difficulty, and Oscar's trying to help him out. I hope you're familiar with the show. Anyway, Oscar's trying to help him out, and Michael's not too bright. And so Oscar says, well, look, you know, one of the things that you could do is you could declare bankruptcy. And Michael says, well, what's that? And he goes, well, you know, all your debt goes away. And he kind of describes it and everything. So a little while later in the show, Michael comes out to the bullpen where the desks are and the people are, and he gets up on the desk and he shouts, I declare bankruptcy. Well, this whole thing reminds me of a lot of times what people do with predictive models, and then they declare them prescriptive models. Like it's just a magical declaration that you can jump from one to the other. It's just like Michael Scott getting up on the desk. I declare this model to be prescriptive. That's really not what happens. And and again, I've seen people that have been doing this for years and years and years confuse this, and I've been guilty too. So it's very important that we understand the key differences there. So I'm going to show you 3 failures. First failure is this idea of spurious correlations. I'm sure most of you have heard of it. By the way, there's a great website. Tyler Vinkin has a website that shows lots of examples of this, and this is actually adapted from Tyler's data. So you can see the correlation between suicides and U.S. spending, right? And this has like an R-square of 98%. So the relationship is too good not to be true. The data runs together so strongly that you almost have to believe what's going on there. But it's happenstance, right? This is nothing more than happenstance, and probably in a different period they're probably not nearly related at all, right? But this happens, and you know, depending on your training data, you create a machine learning model, and this might be a really good predictor in your model. The second thing is a lurking variable, and there's a difference here. So let me go through a little example where I'm trying to predict BMI, body mass index, and I want to use just some simple variables, let's say gender, male, female, you know, the number of hours per week in the gym or fitness center, you know, how much diet soda you drink during the week, and, you know, the age of someone, and then their geographic location, right? So it turns out you can build a decent predictive model just on these 5 variables. I mean, it's not perfect, but it's really not too bad. And so that is a predictive model, right? I can predict someone's BMI based on those 5 variables. All right, so now let's be Michael Scott. I declare this model to be prescriptive. Okay, fine. Well, there's several problems with that. First off, you probably can't change somebody's age, but let's say you could change all of these, and you can even change geographic location. If I move somebody from, let's say, Texas to Colorado or Hawaii, would that have an effect on their BMI? It turns out that Colorado and Hawaii actually have some of the lowest BMI rates that there are. So, you know, if I can turn this into a prescriptive model, then that should work, but that doesn't work. Why? Because the variable of location is a confounded variable. It's confounded by a couple of key variables. One is genetics. Hawaii is a very genetically tight group. And then it's also culture, right? There's a lot of exercise that happens in Colorado. They're more outdoor people. Anyway, I think you get it. The idea is that the geographic location masks the underlying lurking variable. So that's another thing that can go wrong. And then the third fail is this. Let's suppose that I come up with this and I do everything right. So I'm a trained data scientist and I do everything right. I want to predict rain. And so I've got a huge training set, millions of transactions. I cross-validate my model. I do everything right. And I tell you, man, this thing is just awesome. I can predict rain with almost 100% accuracy. And you come back and you say, well, that's wonderful, man. That's awesome. So what's the most important predictor in your model? And I say mud. Okay. Well, that model is not going to work very well for a prescriptive model, right? And that's one of the factors of, it's a condition of causation, right? A condition of causation is temporal precedence. We have to have one thing occurring before another thing. And so this is just another example of failure. So the bottom line is you can't just turn a predictive model into a prescriptive model. At minimum, you need to do three things. Number one, you need to be able to assume or establish causation, right? And, you know, you can assume it, you could be wrong. That's okay. I mean, if you have good reason to think that they're causal, you can do that. And then, you know, if you are wrong, when you manipulate the inputs, you're just not going to get the output that you're expecting. Or you could establish causation, right? You could establish it with statistical method. We'll talk about that in just a second. The other thing is you have to be able to manipulate the important variables, right, within your model for a prescriptive model. You have to be able to manipulate them, and you can't manipulate mud, unfortunately. And then the third thing is, you know, perturbing the system, right? Thinking that you can pull the levers really hard may upset the entire system, and the system may not act the same way in the future as it has done in the past. So you have all this training, retrospective data, then you try to move it forward, and you try to manipulate the variables, and you break the whole thing, and so it's no longer prescriptive. So,
hey, Scott, I'll take a break here. This is Rick. Any questions out there by anyone? We had a couple on the chat line, and actually one of them I had too going, okay, do you work for Dell or TIBCO? What's the story there, Scott?
Oh, sure. So actually what happened was I was brought over into Dell as part of an acquisition that Dell did when they started getting into the data science analytics space. They bought a company called StatSoft out of Oklahoma. They needed some people kind of that had been in the trenches and applying this stuff. And so I got picked up by Dell, and it was really good. Michael Dell decided that he wanted to buy EMC, and so they sold off all of the software, the division of Dell, except for, I think Boomi is probably the last piece of software that's still at Dell. So anyway, we got picked up a little bit later by TIBCO. So I now work for TIBCO.
Okay, now that, because I had the same dynamic and I had a feeling it was something like this. Alexander asks just the sort of the open-ended question is, you know, what is data literacy? How do you define it? I don't know if you've answered Alexander's question there, but
Sure. So it is kind of back to that one slide. It is about having everyone speak a common language, right? Or at least speak language well enough that they understand at a basic level what each other's talking about, is essentially what I'm implying there.
Okay.
And you may call it analytics literacy, right? And I'm going to go through here in a few minutes of some core basic building blocks of that literacy. And again, you don't have to be an expert in any of them, but just to know what they are will kind of help you understand what other members in your organization might be doing that impact some type of analytics.
Great, thank you. Any other questions? Remember, you can virtually raise your hand at any point. Okay.
All right, great. Good questions. All right, so, again, prescriptive models, here's a couple things to consider. If you want to build a prescriptive model, it's best to use experimental design, actually a statistical method with experimental design. That is one thing that statistics is really good about, is being able to differentiate true causation versus correlation or a confounding of variables. So that's where statistics shine. And then another application is Bayesian networks through a directed acyclic graph capability. So these are not naive Bayes or hierarchical Bayes, but they're actually, what's called a DAG, Bayesian belief networks. If you look at that, you'll find some information. And one of the leaders in that for homework is at the bottom there, Judea Pearl, just a brilliant guy. And he's got information. I mean, it's even in Wikipedia. If you look up the ladder causation, you'll see some of his work. And in the Book of Why, he actually won the Turing Prize, if you're familiar with that. And he's an example from, better together. He's an example of education that's better together, because he was a PhD in electrical engineering. He teaches computer science. He's actually an American Statistical Association fellow. So, kind of a Renaissance type person that has multiple backgrounds and just really smart. I have a lot of respect for his work. Unfortunately, he's getting up in age. I'm not sure how much more he'll be able to contribute, but he's laid us a good foundation that we can study. So let me just jump back, because I mentioned model many times. So what is a model in the first place? This is a model. It's 7. That's a model. So most people don't think of numbers as models. 7's a whole number. It's an integer. It's discrete. It's halfway between 6 and 8. It's odd. It's prime, and it pays in Vegas. So, when I tell people that they've never seen a number, they don't believe me. But you haven't, because 7, this is a representation of 7. 7 actually is a mental construct. It is a model. So a model is a representation of reality. It's not reality itself. So, we speak in models in lots of different terms, but it's sometimes good to just kind of take a step back and understand that models are very broad concepts, and they're mental concepts. We make that we make them up. So a couple of comments on closed form and heuristic models. So originally, before I started machine learning, again, I was a statistician by training, and then I got data mining, machine learning education after that. Just to let you know, as part of analytics literacy, is that statistics uses a lot of closed form solutions, and not everything. I mean, sometimes you have to do a search, but the difference is, because calculus, you can actually derive mathematically. solutions in statistics. So a great example is ordinary least squares, right? Or, you know, taking the maximum likelihood estimate or for the mean of, or the sample standard deviation. Those are closed form. We use those formulas, and they're very quick, they're very powerful, but they are also, you have assumptions that go with them. You know, order statistics is another area that you can mathematically prove out. And so you can have mathematical models, you can have heuristics, which are, you know, basically just rules based on expert opinion or business rules. And really what's missing off this slide is the third whole class of models is, you know, machine learning models. And the machine learning models, they actually use computational power to build a search, right? And you build a search space, you have some objective in mind, and then you build a search space and allow an algorithm to traverse the search space and pick up on your objective function, what you're ever trying to maximize or minimize, and then and come up with a result based upon that search. So different kind of models, and each one has its advantages and disadvantages. See, I'm seeing some more questions on the chat. Okay. All right. So, I was telling you up front something that I do that really, I muddle terms together. I muddle the term algorithm sometimes in model, and I know that a lot of people that do this, right? So, really, they are terms that you can interchange. This is just kind of one thing that I put together for like creating a machine learning or predictive model, right? You take the data, the training data here on the top left, and then you mix it with an algorithm. And so between the algorithm and the data, you produce a model, a predictive model, and then you bring in new data and you use that model with an algorithm to score, and then you come up with your estimate or your prediction, right? So just to point out that, you know, when you're talking to someone in an organization, this happens, right? And again, I'm guilty of it too. And it's not really even guilt, because you can, you know, you have a model can be represented in an algorithm. So, and an algorithm can generate a model. So just be aware, I guess, just understand that there can be a point of confusion. So let's talk about business intelligence and visual business intelligence and kind of what they are. And this is one of the things that we go through in the book, right? We try to do the whole landscape, right? So the book is about foundations of analytics, be it BI, data science, statistics, and more. So where did the original BI come from? It really came from this idea of trying to get a single version of the truth. And the story plays out such that you have different people in lines of business. They go into the boardroom. They have all of their different presentations, and it confuses the executives because their numbers don't agree, right? They have different stories. So the whole concept was, let's build a data warehouse. We'll have this single version of the truth of the data inside the data warehouse, and then we can use business intelligence to report that data. So everybody will always be on the same page. There won't be any problem with, you know, what's going on right now with multiple versions of the truth. And so that's kind of this whole idea, was BI sat on top of the data warehouse, providing the single version of the truth. And then it kind of extended into the visual BI, the ability to create images, and humans are wonderful at quickly gaining, understanding relationships with an image versus just a set of numbers, which is hard, really hard to figure out, you know, relationships in tables and such. So, and then there are different types of BI as well. You know, there's operational BI. What I mean by that is, you know, you have dashboards and they're being pushed out every so often. They're part of the operations. They could even be into a mobile device. They could be basically anywhere with the organization, and there's a cadence normally that happens. You know, these things are pushed out ever so frequently. And then there's project-based BI, right? So project-based BI, if you're a data scientist, you know, you may use you know, visual BI visuals to do your exploratory analysis, and at the very end of you may do some machine learning or some stats, and then kind of at the end create some models, and then kind of at the end to tell the executive story. You wrap it up, you do some storytelling with the visual BI at the end. And then there's all other kinds. BAM is business activity monitoring, which means I can push out based upon on something that happens in my data's coming in, something happens, and then based on an event trigger, I can push that out. And you can do that as well with messaging. So that's kind of the concept there. And this is what started it all. This is just like an OLAP, or there's MOLAP cubes, HOLAP cubes, and it was something new that provided the capability to do all this data warehousing and all this quick reporting was this technology that made it available. And then, you know, we love to play with these things. And so, you know, the idea of brush linking, you know, where I can cascade through, right? So, you know, the connection of two or more views of the same data. And when I change the representation in one view, it affects the representation in another. So, you know, I can highlight and it just cascades all the way through, which is a beautiful availability with today's technology. And then also certainly with streaming and geospatial, the ability to even in beyond real time, you know, where you're doing batch, micro batch, you can actually, instead of pulling the data, you can have streaming capability now where the data is actually pushed into the application. And so that's kind of neat. And everybody loves these slides. Everybody loves pictures. I love them too. I think that you need more. I don't think that just pictures is a good idea. And I think better together is the reason better together is part of my story is that I think you can make mistakes when you look at just pictures. And the same is true actually for statistics. And I'm going to show you an example of that. So in the book, there's lots of examples of positives and strengths. Again, one of the things that we try to do is we try to compare the different methods for strengths and weaknesses. And so if you look at BI in general, the different flavors of BI, again, humans are really geared seeing these visual relationships. I mean, evolution and hundreds of thousands of years have really, we've honed this skill. And so we're great at that. And we love to play with things, right? Interact. And man, visual BI is fun. They're fun to create. They're fun to play with. I can click on this and boom, watch this, and you can tell stories, and it's really, really nice. And then it's very intuitive. So someone that doesn't like a lot of math, they can pick up these dashboards and really contribute to the organization as well. And they may offer a single version of the truth if the underlying data is coming from the same source. There's a lot more to that statement, and I'll uncover some of that maybe in a follow-up session. So the other thing, the weaknesses is that the same problem. Humans love these things, right? And humans have strong imaginations, and you can see things in BI dashboards that do not exist, meaning that there really is no relationship there. You're looking at this thing, you're saying, wow, if I, you know, do this, then so-and-so happens, or, you know, whatever. We do have strong imaginations, and a picture is not a good conclusion oftentimes. Again, very good for discovery, very, very good at the end, in my opinion, but you should not rely solely on graphics. Also, they're historical, they're retrospective only. You can't really view higher order relationships with these things, right? I mean, you can't see 5 dimensions in a graph, but you can do 5 dimensions easily in machine learning. So that's a problem. And then the cognition is primarily in the head, right? So it's not always effective to do that. All right, so let me pause here. Let's see if there's anything in the chat. Help me out.
We do have a question out there from Alexander.
Okay. All right. On the slide algorithm used in model creation, there's a direct link, historical training data to predictive model. Well, all the data, regardless of the source, represent the past, what already happened. Is it always possible to predict the future, build predictive model based solely on the past? Is anything else needed besides the data to develop a predictive model? So, I mean, the way it's normally done, it is done from historical data. There is a whole area of, actually it falls under statistics called Bayesian modeling, where you can build the expert knowledge into a model. That's one way to do it. Or you can do things like simulation with an expert opinion, right? So when I showed you that like heuristic model, you can build predictive models based upon your knowledge, right? Just a set of rules, a set of like if-then statements. You can build predictive models that way as well. Especially if you're just getting started and you have no data and you want to put some sort of something into action, you can do it that way. So I hope that helps. And then, the goal would be to start collecting data, right? And then make sure that whatever model you created is, you can verify it.
We also have a question from the audience from Yelena. If you want to unmute, you should be able to talk. Yelena, I think you need to find the unmute key. Oh, hand is down, so.
Okay. All right, well, if you have it, if you want to, we can come back to it, or you can put it in the chat. Either way, it's great. All right, so I know, how are we doing on time? I can go faster, I can skip some stuff, or can I just continue on?
Keep going.
Yep, I'm fine with that.
All right. Okay, great. All right, so this is a great example. Data mining and machine learning, is there really any difference? I mean, this is a great example of the hype cycle that I was talking about, right? So yes and no. Historically, there's a big difference, right? So when you look at data mining, it's fairly new. Machine learning has been around since the 50s. It was, I think 59 is when you started seeing machine learning come out. It came out like 2 or 3 years after AI. And then data mining didn't happen until the 90s, the mid 90s. And if you like KD nuggets, that whole thing is knowledge discovery and data mining. That came out of KDDM, out of a conference back in the 90s. So Fayed and Greg Shapiro, they had done some stuff there. So, but from a practical standpoint, no, they don't. In fact, my master's degree that I got a few years ago was in data mining, and just because that was the in vogue term at the time, essentially that same program would be data science today, or a machine learning program, which machine learning programs aren't as popular. So where do they shine? So they let the computer do most of the processing, right? So in machine learning and data mining, they shine over BI by using the computer, and they're mathematically verified, right? So meaning that instead of looking at a picture and having a human decide, well, that looks to me that goes up when this is there, that goes up or whatever, that may not be true, right? I mean, mathematically, it may be kind of that spurious relationship, or even, you might need more than just a picture. So And again, this is kind of a common theme in the book, these pluses and minuses, and I'm just trying to hit a few of the highlights to impart. So data mining and machine learning, some limitations. It certainly requires more education. And where's the fun? You know, again, BI is a lot of fun. Visual BI, creating dashboards. Most people really get a kick out of putting those things together. And so there's that. And then, you know, the total cost is higher. But again, I go back to better together. They're not exclusive. You can use both of them. I mean, again, my original thing is, you know, you get some data, you create some visuals with it, the data, to try to understand the relationships. Then you test out your hypothesis or what you're thinking with some sort of statistics or machine learning, and then vet that out. Moving on to artificial intelligence, it turns out, and I actually found this out, I was kind of surprised, because I thought really machine learning was well before AI. Turns out no, AI was actually around in the mid-50s. It got started at Dartmouth, and machine learning hit in the late 50s in '59. And again, all of this started with, you know, the invent of computers that could do a lot of this processing for us. And the whole idea behind artificial intelligence was, you know, you look at the brain is wired by connecting a bunch of neurons together. It's not the neurons itself that hold the intelligence. It's actually how the neurons are connected, synapses that connect these things together. So it's really the interrelationships, and then they try to do that with, you know, creating a simple neural network. So I have one here where, you know, it's a simple input layer and one hidden layer, and then an output layer. So you start on the left side, again, with your data, and then you have a set of weighting functions, and then you push in, and the computations here are, there's a lot of computation. And if you look at deep learning, it's basically kind of along the same lines, except you have really a lot of hidden layers and a lot of computer processing that goes on as well. So just to let you know, I won't spend a lot of time on this for brevity, but you know, there were winters where AI was kind of really in vogue, and then you didn't hear much about it, and then it got really in vogue, and then it would kind of go away. In that 80s scene, I joined Texas Instruments in, let's see, 87, and Texas Instruments actually made a microprocessor to do artificial intelligence based on a Lisp. Also, there was Apple Computer had the Lisa. So there were special machines that were developed specifically for AI. Kind of cool stuff. So where does AI shine? It's extremely powerful for nonlinear and pattern recognition. I mean, you know, you do some sort of image recognition, facial recognition, even video streaming, etc. It's great at picking up those patterns. You know, you for many problems you don't even need to any sort of label. Whereas in machine learning, you typically have some sort of label that's defined. Sometimes you can circumvent that with artificial intelligence, and really great results with unstructured data, right? So natural language processing, text analytics, things like that. It really does shine. Now, there are problems. One, it requires a lot of data. If you're going to build up AI models, you really need a lot of data, because again, you're going through all those different layers. It's building actually tons of different models and trying to figure out all the different nonlinear relationships. So you need a lot of data to do that. The biggest thing is they're not transparent, meaning that you can't understand them. If I provide you an ordinary least squares regression, and I say for guessing the price of a house, you multiply the number of bedrooms times, you know, $40,000, you can understand that. I mean, it's a formula. I mean, if I do like a machine learning classification and regression tree, you can walk the tree and tell exactly what's happening there, but you cannot understand what an AI model is doing. I mean, the model has the weights, it has all of that. You can look at that, but you can't, as a human, you can't read that and make sense of it. So this whole idea of transparency is really coming up, especially in Europe, if you're familiar, like GDRP and some of the things. They don't like these black box models, especially in medical science. They don't like them in financial. They want to know how the model is working. So AI gets a fail in a lot of circumstances along that. And they encode correlation and not causation, so you really can't distinguish the two. And there are actually many more. They're wonderful for certain problems, but you have to be buyer beware. So this whole idea of data science, it was really created around 2000. And again, so we see a lot of the same stuff occurring. It's coming up with different names, but a lot of the underlying stuff really hasn't changed. I mean, if you look at the person that created this term data science, he was actually a statistician. And you can see the heavy emphasis on this. This is kind of what he outlined, statistical methods, and then he adds in, machine learning methods, computational environments. The thing that I like best of this definition is that live analyses of data where resulted are judged by the findings, not the methodology and systems, again, better together. So it doesn't matter necessarily how you came up to the finding. It's more important the outcome, right? And so that was kind of the motivation. Data scientists are kind of unicorn. It's really kind of hard to get everybody that has all of the different talents and everything in data science. So what's happening is, instead of trying to hire a unicorn, the specialties being broken out, and you'll see, data scientists, you'll see data engineer, which data engineers are more on the piping. They're really, in many ways, more technical, sourcing data, being able to deploy models, et cetera. Then there's a whole advent of citizen data scientists, people that are either new, don't have quite as much technical expertise, or don't want that, where they can contribute subject matter experts, and then developers. And again, it's really a team sport, right? It works better together. And it's also today's university hot term. So I have affiliations with SMU, Northwestern, and CUNY. And so I've taught at Northwestern and CUNY, and they've renamed their programs while I was teaching there. Northwestern was predictive analytics, now they're data science. CUNY was data analytics, and now they're data science. So again, these things are morphing as we speak, because everybody wants the new hot term to go with. For sake of time, I won't go deep into big data, but really it's both a term and technology, right? So you have the term, and you can do your homework on this, but essentially originally there was 3 V's: volume, variety, and velocity, and then they added 2 V's of value and veracity. And so it's a concept, and then it's also a technology. If you've ever heard of Hadoop or Spark, those things were built specifically to solve the problem of moving data. So instead of moving all the data to your machine learning environment, it was being able to push the algorithm to where the data lives, and that's the technology that supports big data. And then I'm just going to skip that altogether. So let's talk just a little bit about statistics and this whole idea of causation, because again, statistics really are needed when you need to determine causation. So we talked early on about diagnostic, prescription, and optimization. And so they're the questions that we were trying to answer, and all 3 of those require a causal model. So you need that. And they're very well established, right? They're very accepted. So a lot of government uses statistics. They don't yet. So far, they're really not accepting a lot of, let's say, time series done with a neural net. They like ARIMA. They like statistical models. So you have that. And then there's some different types of statistics as well. And this is one of the things that I love. So most people don't even realize, you know, I've seen articles that say machine learning makes statistics obsolete. Well, no, not really, unless you misunderstand what statistics is. And that's because any machine learning you do is using statistics. There are 4 basic definitions: populations, parameters, samples, and statistics. A population is anything of interest to you as a researcher or as a person trying to figure out a problem, right? You define whatever the population to be. The parameter is a characteristic of that population. A sample is any subset of the population that you're interested in. It's any collection of objects in your interest is a population. So any subset of that would be a sample. And then any characteristic of that sample is a statistic. So when you do machine learning, you are doing statistics, period. You take a population. We take, you know, we want to, I don't know, reduce churn and you know, customers. We want to keep people from leaving our service. So what's the population? All of our customers, not only current customers, but future customers. So we try to build a model that will project into the future. So that's our population. We can't even get at all the elements in that. And those parameters, let's say, churn is, you know, 0, 1. They're not. Some of the things that might affect that are how long have they been a customer, how much do they spend with us, how many customer calls do they have over the last 2 years, et cetera, et cetera. So those are all the parameters of the population. And then we take a sample of that, we build a machine learning model, and then the outputs of that are actually statistics. So you cannot do machine learning without statistics. So when I see something like machine learning makes statistics obsolete, it kind of makes me go off the rails. So the other thing is machine learning will never replace a lot of the methods. I mean, that example, you could do, like, let's say ordinary least squares, like a statistical model, or you could do a machine learning model. But there's lots of statistical models that you can't even replace with the machine learning model, like process control or time series, you know, randomized control trials, et cetera. So these are just examples where they're not going to be replaced by machine learning. This is another admission of me of, you know, missing something totally in my earlier career. When I was at Baylor, you know, statistical inference is hard for most people, and that causes people not to like statistics. And it is true. So very, very important is what problem you're trying to solve. So I read this thing when I was at Baylor. I was teaching there. I was also a student there, and there was this article in American Statistician or Chance, and it said, was Ty Cobb a 400 hitter? Well, I thought, well, that's crazy. He hit. I mean, you look it up in 1911, 1912, 1922. He hit 400 3 times. So of course he was. That was not the question they were asking. They were asking whether he had the capability to generate a process of hitting. Not did he ever, in other words, in one sample point, in 3 sample points, he did hit 400. But I totally missed it, because the point is, it's a process that you're trying to determine. It's not whether he ever did or not. So questions are really important. And in fact, Einstein had said something like, you know, I'm not sure if this is real or somebody made it up, but they said, if you had an hour to solve a problem, what would you do? How would you break out your process of your thinking? And he goes, the first 50 minutes, all I would do is try to understand the question. And then I'd spend the last 10 minutes solving it. So just very important to realize that the question is often more important than the technique itself. All right, and we won't get into model free. Maybe I'll come back and talk about parametrics and robust statistics and that kind of thing. I'm going to gloss over this too. I did a LinkedIn article on this. I've actually done a few LinkedIn articles, kind of debating these different topics. I've got the Ty Cobb one half written already. I should post that in the next day or two. I'm going to blaze through these because I'm taking too much of your time. So again, the statistical limitation does have a steep learning curve. It's also the blind men and elephant problem, because people talk about not liking statistics and not even realize what they're talking about. You know, they view it as like inference or, you know, significance testing or something like that. Well, those things are sometimes hard, but that's just one little slice of statistics. They do require assumptions, and again, maybe I can come back and talk about that. But better together, statistics should not be used solely. This is a great example, and it's Anscombe's quartet. This is a statistician that put this together. These 4 panels, actually different data sets that produce almost the exact same statistics, but a much different picture, right? So understanding this data, I wouldn't want to just look at the picture. I would want the complement of the statistics along with the picture. And again, that's better together. You know, then and now, used to be, I remember as statistician, you know, the assumption of normality is too good not to be true. In other words, some of the models require normality assumption to be made. And that is sometimes, you know, and it's pretty forgiving in all reality, but I like the idea now, the promise of AutoML, the ability that you just throw these numbers in a computer and the computer's going to come up with the answer for you. It's all automatic. It's automatic machine learning. It's too good to be true too. So I just want you to think about that.
Hey Scott, we do
yeah.
have a question. I am opening up Christine's line.
Great.
There you go.
Hello, Scott.
Hi, Christine.
Hello. Thank you so much. It was a great overview of data science and data analytics. Really appreciate it. You obviously you're a Renaissance man yourself. You talked about data literacy and better together. I just wanted to say, I'm with the University of Wisconsin, Milwaukee in the continuing ed school. And I would say that our audience are post-baccalaureate and pre-masters. Many of them have jobs as kind of, in some way, they're analysts. They have analysts in their job title. And they come to us to learn more. You know, they just really want to get deeper into being those citizen data scientists. And in your opinion, what are some of the skills, some of the courses, some of the skills that we could offer that would serve them the greatest to help them be more effective in their organizations, to help, you know, just help the overall cause? What comes to mind?
Sure. So I do think a stats class is very important. I think that, but I'm going to condition that on it being a good stats class, because a lot of stats classes are not good. I wish, and maybe somebody's written one recently, I just haven't seen it, that takes the approach of statistics in a very different vein. But the way it's normally, the textbooks are really pretty dry. But I do think that the foundations of stats is great. The idea of basic probability, and most stats classes do cover probability, because we're bad. Humans are bad at making judgments under uncertainty. So that does help. I think BI is great. Like I'm sorry, when I say that, I mean like a visual analytics type dashboarding type class. I think that most people really like that. It gets people fired up about it. But again, you have to be sure that you don't limit it to that, because again, you can make a picture. I guarantee you I can put a PowerPoint together that supports anything that I want it to support. virtually anything. All I have to do is pick the right columns out of the data set. If I have a large data set, I just have to pull the right columns and put them together in the right way, and I can tell any story that I want to. And that's the problem with visual BI, is that you know, math doesn't lie, and you can lie with BI. Man, maybe I should write a book about that. Anyway, so that's a couple, and it's a good that's a good interplay between the two. I mean, depending on what level of, you know, technical capability that they want to get into. I mean, there's certainly some others, but you know, a basic machine learning class too, because machine learning is pretty intuitive. You know, predictive modeling class, that's pretty intuitive stuff. People get the idea of, you know, separating the data out, having the machine build, and there's some algorithms that are very intuitive too, like, you know, K nearest neighbor. You know, you get the idea that you want to make a prediction, you want to train and build a model based on a history of being close to like observations. So that's three.
Those are
but you know,
helpful.
Yeah, reach out to me. You know, I'm by the way, I should have said it a long time ago. I've got like 2 slides left, or 2 or 3, and,
Sure.
and one of them's going to have my contact information on it. So we can certainly pick up on that.
That's great, and you're validating some things we're doing, and you're giving me a couple ideas for something more. So I really appreciate that. If I could ask just one more, this takes it up even a higher level than that question, if you can imagine. One of my favorite consulting groups in the U.S. is an outfit called Birchworks, and they deal with data scientists and marketing analysts. And they just came out with a survey. They're going to do a webinar next week that paints a fairly bleak picture for jobs for in this area, much to my surprise. So I took a deeper look, and I looked at Greater Milwaukee, and it's pretty much what they say. Can you make a case in a couple points about why we should encourage people to study data science and data analytics in the down economy?
Oh, I mean, my whole mind is that direction. I mean, that's difficult, because I mean, I can't imagine a world where you're not wanting more analytics. And again, we've been talking about being data driven for years and years and years. It's not the technology that's lacking. It's the vision and application. And I hold great promise that the organizations that I talk to are wanting to certainly do this. So I think there's a lot of interest out there. The other thing that I would really push is, the great thing about being a data scientist has nothing to do with geography. I mean, my company's based in Palo Alto, and I never set foot in Palo Alto. Before COVID, I used to go out to customers, you know, and visit with customers. But I mean, I wouldn't let a local problem, you know, stop me at all. Does that help?
That's wonderful. I took a few notes from that, and I thank you so much for your comments. You've been very helpful. You bet.
I mean, yeah, I mean, with this type of work, you're not bounded by geography at all. I mean, I have students, by the way. So I teach in CUNY. I teach in the master's program in data science, and I have students all over the world. It's not a problem for them to be there. It's not, and I have students that work and never, kind of like me, they never set foot in the office. Everything is virtual. So in overall, the demand is really good. And I hate to plug the book, but in the book, we have a lot of statistics on the hiring. You know, statistician is the sexiest job in the 21st century, things like that. I mean, there's a lot of that. So anyway, a couple more just quick points. There is no free lunch, right? So there's this whole theory, I love it, that, you know, there's no methodology, there's no algorithm that's universally optimal, whether it be method, technology, whether it be people working together. it is better together. So there is no free lunch, and you should be versed in several concepts, at least so that you can have an intelligent conversation. Technology is important, but again, asking the right questions is more important. And you have to understand that data is all about process. Anything that's collected is part of a process. And again, maybe more on that the next time. And again, I encourage you, this book is out. And then to let you know, coming next year, we've got a book coming out in early 2020, and it's going to be about the organizational design, the data architecture design, and then the analytics architecture. So those three major components as part of the book to make your analytics successful in your organization. And then here's some contact information, especially on LinkedIn and then a Hotmail address. Twitter, I'm not all that active, but I do check it every now and then. Okay. What other questions?
And I'm opening up all the lines for anyone to free form. We have enough, we can manage it. So anyone can unmute their phone and ask a question.
Let's see.
Come on, you don't know what kind of prize you might get for asking a good question.
And who wants the
By the way, Christine, I am familiar with Birchworks, and so Birchworks is actually, if you know those folks, I think I used to know Linda. I quote them in the book. So.
Oh, really? I think they're fabulous.
Yeah.
And I love their reports on jobs as well as tools currently being used, I think are great. I follow them all the time. I agree. They're wonderful.
Hey, Scott, isn't Linda down in Chicago?
Yes, that's the one.
Yeah, I know. I mean, no, Linda's been around as long as I've been around.
Yep.
So
Excellent.
I remember at Smith Hanley, so I'll lay that out.
Another familiar.
Hey, Dennis, you got a question? Ask away.
Actually, I've got a comment. I think if you look at the value of this from a competitive standpoint and where we are in its implementation, I mean, this man that's been talking for more than an hour now has got a PhD in this. He's done it his whole life. It's clear that it's a huge topic. There's a lot of things that you have to know how to do correctly to get it to work correctly, and probably not everybody in the world that's practicing this is achieving that. So I think as people get more and more used to it, we get better with it. It'll go from this thing that's sort of an out there topic to something that's necessary to be able to compete. So I would tell my students, if I were looking at the next generation, this is sort of like space exploration. We've done some of it. We know a lot, but we're clearly learning by the minute, and it's being adopted by more and more companies in every area of enterprise, and it's not going away in spite of the fact that there might be a near-term drop in employment opportunities. So I see it as a competitive foundation that will be a requisite for future organizations.
That's excellent. Absolutely. I wish I could have put it that well. And I am in space, right?
Anyone else?
Yeah, this is Kathy Henrich. I'm the CEO of the Milwaukee Tech Hub Coalition. And I liked your point about
Kathy, you're not coming in.
Approach to
Oh, you're breaking up a bit, Kathy.
data science. One of the challenges right now, though, you brought up, able to define those. Sorry.
Oh, crap. She had something good to say. Kathy, could you try to call in or type out your question, because we couldn't get it.
Yeah, because Kathy is now CEO of a business academic coalition for IT technologies and data science in the Milwaukee area. So bringing, industry, academia, and the people all together. So, she's one of our local driving forces to gather up all the folks together. So it's, which is always a challenge with an eclectic, community.
Yeah, Milwaukee's in an interesting space. We're sort of in the shadow of Chicago in some ways.
Yeah, but I think we should be drawing those people up here. So David, you got a question? Go ahead.
Hi, Scott. I'm a recent graduate with a master's in data science. So I am out there looking for work. My question for you is, if you were going to interview at a company, do you have any specific questions of the potential employer as far as data literacy goes?
Well, it certainly depends upon the position. So I personally have used in the past and think it's probably the most effective way to interview is basic problem solving skills. To give someone a problem and see how they approach the problem. What kind of approach do they have? Because I know people that are hiring want you to know very specific things like Python or R or Java or Scala or whatever it might be. Certain techniques, do you know NLP or whatever? But to me, those are the simple things. I mean, it's the foundations. It's how do you approach a problem? And so Mike and I, we worked together, and it was an eclectic group. It was wonderful because we had physicists, we had econometricians, we had computer scientists, we had statisticians, we had just a variety of different backgrounds.
Yeah.
Solving, basically, we were all working on pricing science, but we're all approaching the problem a little bit differently. So industrial engineers and operations research people, they look at every problem as an optimization problem. They look at, okay, what are the constraints for the problem? What is the goal to be, at? I mean, as a statistician, I would look more at it as a statistical, so you have these different events, but in the end, you can have two people approach the problem from different angles, but if their thought process makes sense, to me, that's the way to hire. It's not very basic skills. It's problem solving.
Great. Kathy had typed up her question, and it's come up before along the way at different ones that we have had about the plethora of roles and definitions from, the data engineers, all the way to data scientists and, the varying degrees of activity these people have with the organization. And I think it's a bit of a mess at times to have people understand all these different roles, and even organizations themselves often have varying degrees of what roles mean. What's your perspective of exactly this, of what all these types of roles are? And I think the team sport plays it out, because that's what most of the leaders of these groups discuss, is having the right mix on their team.
Right. Absolutely. And so we do cover some of that in the book. And specifically, we talk about, the fact that the data scientist was too broad. They were unicorns, right? So they wanted you to be able to source every kind of data that's out there. They wanted you to be able to, do all of the plumbing, all of the acquisition, all the cleansing, all the data modeling, all the data validation, all the deployment of models, the storytelling, the visual BI, everything. And that's just too much for one person. So although I do think a good data scientist will know a little bit about all those. In fact, everything I presented, I think a data scientist should know the basics of. But let me tell you, I work with someone that is far, far better at data engineering than I am. I mean, the ability to speak in terms of microservices and different types of APIs and event processing and, Docker and containers and, all kinds of stuff. I mean, he's a data engineer. And so it's a different discipline. We work well together. In the past, I've worked with what would be considered as the citizen data scientists, people that were either new and, just learning, and they could bring a lot to the team, but maybe not go real deep just because they didn't have that level yet, or someone that doesn't want to. I'll be honest. I mean, I got to a point in my career that I was very specific about what I wanted to do and not do. And so you have some people that just don't want to be a gearhead. They want to be more, closer to the business. So the citizen data scientist often plays between, the hardcore function of the data scientists and engineers and closer to the business and crosses that chasm. Much like the business analysts used to. The subject matter experts on the line of business side are certainly part of the team. The developer that codes up, let's say, an application to present to the business the results from all of these predictive models that are being created. So it is a team sport is the way I see it. And there's many positions that aren't even listed here, but these five to me are kind of a core team in a data science. And also the structure, again, I know I'm plugging, but we outline different organizational structures as well. And the next book is going to talk a lot about the organizational structure to support the, what should you have a chief analytics centralized office, or should you have chief data officer? Should you have distributed people within the lines of business that don't report up into a centralized group? So there's advantages of both. So there's different ways to approach it. And so.
Great. Anyone else? Come on, we haven't kept you from dinner yet. I know some of you ate during this session.
I can smell it through the network.
Hey, I bought corn on the cob at a local farm stand locally. So this is in Wisconsin. This is prime time corn days.
Well, there's no other questions. Hey, pitch your book, Scott. Show them the discount on the last page. Your flyer.
Oh, yeah. Yeah.
The hell, sell the book.
Oh, well, you know what? I don't have. So we can get you a 20.
Here it is. I'll repost it again. I had it in there.
Oh.
But don't broadly put this out there. This is just for you guys. Thanks to Scott, and it's a 20% discount if you had to go to the publisher, and then the code. There is a code. I'll find it. Hold on.
You do have that Breaking Bad look going on, Mike. So.
Yeah, I got a hat here today, but I do like the hat though. I don't know chemistry, so don't worry about that. So there you go. Those are the two things. It's out of Routledge or Routledge.
Yeah.
And if you type in the code SOC 20 at checkout, SOC 20, you'll get 20% off. So there you go.
Appreciate that, Mike.
No problem.
And I appreciate everybody's time. I really do. This is something that I'm a really big believer in education, and so I really appreciate you having me on.
Hey, how about a year from now? Come back and tell us about the second book.
Absolutely.
Okay, keep that in mind.
Absolutely.
It had to be virtual. See, we're benefited by the fact that I was able to use my broader network, which includes since we're all virtual now. But you know, we'll see if we can repeat this. Hey, thank you everybody for coming out tonight. And if you have any ideas on topics that you'd like to cover, or if you know people who are interested in speaking to us in a virtual manner, they don't have to be located in Milwaukee. Let me know, let Rick know, and let Randy know. And we're the three organizers of note that keep this organization going. We're got about 1,500 members. We run 9 to 11 or so events per year. We used to have, when pre-COVID, we had an annual conference. Would have been about last week, but we had to cancel that. As of late, it was, how many people did we have last year, Rick? Maybe 400, 500?
Yep.
At Marquette, 2 days, and we had some national speakers come in. So it's we really got a lot going on here. I think there's a nice community here in Milwaukee as far as the sort of data-driven world, if you will. We're eclectic in who we have speak. We could be anything from Hadoop to organizational issues in data. It's all good. So, but we just want to keep it interesting. And Scott, you did that today, and I want to thank you. Thank you for allowing a guy that you haven't seen in 15 years or so, come up and help me out there. So, and I appreciate that, and I know the folks listening in today do as well. So, thank you again. Thanks, everyone.
And I'll post up the link on our meetup site once it all captures the recording.
All right, you take care now. Thanks, Scott.
Thank you.